divide up the recording and let's do another one here. How about this one? For example, F is going to go from the real numbers to the real numbers, and I'm going to send X to X plus 1 cubed. So from the real numbers to the real numbers, and I'm going to send X to X plus 1 cubed. Here's my scratch work. And again, I don't care if you put this on your homework, that's fine. It's not technically a part of the proof, but if you want to put it on your homework, you can. Just make sure you label it as scratch work so I know what I'm looking at. So we would need F of A equals B, or A plus 1 cubed equals B, right? That's what I'm going to need. Please let me do 2 algebra steps at once and say that A is the cube root of B minus 1. The minus 1 goes on the outside, right? Cube root of B minus 1. You guys can all do that algebra. You're fine. You're good. Okay. Are there problems with that? Remember that B lives in the real numbers. Are there any problems here? Anything for problems with this equation? Thumbs up, thumbs down. Problem, this is stupid. No problems or problems? What do we have? No problems with this equation, everything's good, or we've got some problems with a certain value of B. What do we have? I am getting thumbs up from people and other people not willing to commit. Yes, no problems for this one. If B lives in the real numbers, no problems. All right, so this is going to be a proof. And so we're going to let B live in the real numbers. Choose A to be equal to cube root of B minus 1, which lives in the real numbers because B lives in the real numbers, and we are using exponentiation and subtraction. Again, exponentiation with fractions is potentially problematic with the integers. It's okay with the real numbers. If you've got cube roots, no problem there. And then remember, my need to show is that F of A equals B. So we can do a we know that. We know that F of A is A plus 1 cubed. So that's going to be cube root of B minus 1 plus 1 cubed. Just plugging in what I picked A to be. That is cube root of B cubed, which is equal to B. That's good. That's what we wanted. That's my need to show. And so we can say, therefore, F is surjective as desired. Good. I'll let you finish copying, and then one more surjective example. We've got one more that I want to do. Anything for questions up to here? Doing okay? Does the scratch work help? Kind of help you figure out if there's a problem or not? Maybe, kind of, maybe. All right, one more. Last one for surjective, and then we're going to talk about function composition a little bit. For example, one more time, F is going to go from the real numbers to the real numbers. X is going to get sent to X plus 1 squared this time. So last time we had X plus 1 cubed. This time we're doing X plus 1 squared. X plus 1 squared. So scratch work. We need F of A to equal B. A plus 1 squared needs to equal B. So we need A to be the square root of B minus 1. Looks very similar to what we had last time. Are there problems? Are there any problems with this? Remember, B is living in the real numbers. Any problems with this? People are nodding at me. Josh, you're nodding at me. Give me a value of B that lives in the real numbers that's going to cause me a problem. Problem if?
E equals -5.
Sure, problem if b equals -5, which does in fact live in the real numbers. Yes, that's going to cause me a problem. Problem if b equals -5, which does live in the real numbers. So this is going to be a disprove. And then we are going to say, choose b equal -5, which lives in the real numbers. Then we would need a to equal square root of b minus 1, which is the square root of -5 minus 1, and that does not live in the real numbers. You got to be a little careful with your does not live in. Make sure your does not live in is totally and completely obvious. But in this case, we know that square root of negative numbers is not a real number. So in this case, our does not live in is pretty obvious. And we can say, therefore, f is not surjective as desired. Not surjective in this case. There are a ton of different b values that could give us a problem. Any negative number in this case is going to work. So any negative number, you could pick a different example than someone else did, and that is totally fine. Not a problem. Okay, everybody caught up writing? I'm gonna stop sharing my screen. All right, lovely. Questions on surjective? Anything at this point? How are you feeling about surjective? Give me a meh, kinda, sorta, kinda, maybe? Okay, I would highly encourage you to write out the scratch work. That is gonna help you a ton until you get a better feel for prove or disprove on surjective. Don't even think about, am I proving or disproving, until you write out the scratch work. Once you write out the scratch work, that should lead you to prove or disprove. That's my first encouragement. My second encouragement is think about what causes problems. Dividing integers causes problems. That's going to cause me issues, right? Taking square roots or even roots of negative numbers causes me problems. So that's a potential place for a problem. And then, I don't know if there's any on this in the homework, but taking logs of negative numbers or of 0 causes me problems. Those are kind of the big places where you're going to have problems in math. I said dividing integers, taking roots of integers is also going to cause me problems as well. So just kind of keep in the back of your mind, what are the sets that I'm working with and where might I have problems? What operations might cause me problems on those sets? That's a good way to think about your scratch work. Okay, any questions before we jump into the beginning of section 12.4? Today is just kind of a split day. Anything? We're good? All right.